Hello,
Yeah,
everyone.
it's got my name on it.
Hello. I'm Elisa Perez Bustos. That's John Gibaldi and Robert Rathcam. I can't say his name. We did a drone. We did it for research purposes, like if a scientist needs to get a sample of dirt, water, they can just fly the drone whatever they have to, even if it's a faraway place, like a place where they can't get access to or is dangerous to go to, they can send the drone to do it. And that's pretty much what our project is. And
this also allows by using the drone, we named it the DeVry Collector. It allows it protects people's lives as maybe as Elisa said, hazardous areas. Maybe there's too much radiation, or maybe there's maybe near rocky cliffs or in treacherous terrain. You can send the drone instead of sending personnel to collect samples.
So the FAA regulation, there's actually two types of licenses that you could get. Well, for this one, this is for the Fly for Fun. It's pretty much for recreationals. You just register and you only pay for like $5 for it too. So like for our drones, in order for us to test it out outside, we actually had to get that, and we had to put the serial numbers. So but you could use the same exact number on as many drones as you like. Next one. Next. Oh wait.
That was
So for the Fly for Work, you do need to get a license for an actual piloting license to use for commercial wise or anything or governmental. So pretty much the areas that you could do is limited here in the city. Well, not here in New York City, but like Corona Park, you could actually fly through there if needed. But over here in Central Park, you can't do it all.
You also can't fly near, I believe, 500 from airports.
No, 4 miles actually. 4 or 5 miles. You can't fly near the airport at all because due to the radio frequency, it could either do some interruptions on the plane's communications,
or it can run into the airplane itself.
Yes, and of course you can't fly to the city because there's moving vehicles at all, and you could damage any other stuff as well. Yes. So these are the parts, the hardwares that we use. We use the Lynx Motion Quadrino Nano. It's based on Arduino. Of course, we get the propellers. For this one here, we actually use a 8 by 4.7. It's for slow fly, so that it could hover up slowly. And then we have the cameras as well, so that we could see in the first person view. And we have the battery, the LiPo batteries, so we have 3,000 mAh with a 30C, and the micro Mandis. In order for us to actually pick up something, so something like a rock or anything like an object or another drone itself. So next. And of course we have the multi-star, the 30 amps, the speed controller. We got the 4-in-1 because it's lightweight. Instead of getting 4 types of ESCs, we get the 12. Of course, because since we have 2 types of drones, there's the other one has the 12 amps with the 4 ESCs, the prop drive, brushless motors, and of course the 2 types of drones. So these are the diagram. This side over here is the 4-in-1 ESC. It's very much the same exact features of the other, just the individual ones. We get the 4 motors, and then we have the flight controller, which connects to the battery and the receiver. And we got the pump, which
this one.
well, we were trying to move it back and forth. So we have the pump over there, but the suction
container
is right here,
for the sample.
Yeah. And then we have the camera, and then the 5-volt regulator to control the camera voltage. Next. So pretty much we use the Arduino to program the flight controllers, the links motions, and in order for us to change the PID gains, we had to play around with the roll, pitch, yaw, and everything else here. But it's a tough project. Until now, we're still having issues going back and forth, trying to get it up and running properly. But we were able to fly it, actually downstairs at the 10th floor. But we waited until everybody was gone. Yeah. But we do have a video though.
Turn off the volume.
Should be like that.
What happened?
It's playing. It's loading.
Loading. And then you could get the one on your phone though.
Change the priority. Set it to a higher priority.
For some reason it's still loading.
Why you need it to that?
That's why it's
Now, should
Oh, just that the episode.
Terrible.
Yeah, what Tom was in it usually.
The teacher doesn't care. She still.
You want to try to open it? Yeah, go back to Explorer and open it using another player. Right click. Open with something else. Nothing really.
No, just me.
You guys try it again, but this time open the task manager, go to processes, and set the task priority to high.
I say just light it on fire, see if that makes sense.
Well, you're close. It is.
Maybe Control Alt Delete and then shut it down.
I'm telling you, do the task
Okay,
manager.
so Task Manager, yeah. Then
Go to
shut it down.
details.
Maybe this will work.
Windows Media Player having an issue.
Yeah, of course.
Yeah.
Oh, wow. Right.
Last hour.
Novel idea.
It's Windows.
Okay. Now try Red Collector.
do right click.
Close. Try it one more time.
Do right click and open it with a loader.
Yeah, but there's nothing else.
There's nothing else.
There's
Oh,
nothing
that's-
else.
It's really resource hungry, guys. I'm telling you.
Really? Is it a huge video or?
Oh, you
It's
mean
1 minute.
Yeah, it's only 1 minute. Try the other one.
Okay, let me see maybe the other one. Please.
But it's Windows Media Player that's not working.
Yeah, that's
So that's gonna.
To be fair, I actually never seen it work.
Yeah, so right click. Yeah, try the other video.
Okay,
Okay.
that one works.
Oh.
But that's the bloopers, though.
This is the bloopers.
Hey, look, there's dramatic. Failing.
Half the time that was the result.
That's not bad. That's good. That's it. No.
Oh no, it's the music's just.
Oh, that's with the clock.
Yeah. Didn't tempt him with it, but
That's not bad. It works.
that was with the old flight controller, but for some reason the USB port came off.
I don't know.
Did I try this at home?
Oh.
They actually cut the part where I was screaming "cut it" because
So-
John actually went faster with it.
We're still having issues with the stabilization to it because due to the claw, it's the claw is swinging, so the flight controller is trying to control it, trying to stabilize it as much as it can. So probably with a chain or something like that going down the claw, that it might help out something. Because right now we're just using as a cut off USB wire with a mesh guard on it. Yeah.
Question, anyone?
Yeah.
It's pretty good project, you know. My question is, did you guys tested how long your battery would last, or how long the flying time?
It really depends on the battery. Before we were using just the 1500 mAh battery, which only lasted for about 30 minutes. Mm-hmm. But this one here, we're using a 3000 mAh, so now it's about an hour.
And is there a limitation in terms of the weight it can lift? Does it vary again with the?
Yes, the limitation is it really depends on your motors. So if it's a I'd say like a 2200 kV brushless motor, then it could go pretty up. Yeah.
So approximately how many pounds it can lift right now?
As of right now, it could lift about 15 pounds.
15 pounds? Okay.
Yes.
That's pretty good.
And we since this one over here is the motor is it's a lot more heavy duty than the other one, and this one has the 30 amp ESC. That one has the 12 amp ESC.
For the
It's pretty good.
Yeah, battery would last less. That's what it is.
They're using drones now, especially in Africa, to transport blood for remote hospitals.
Right.
There are TED videos, you may be able to see it, where the doctor gets a text message a minute before the drone goes there, so he would go and wait outside, and then the blood is dropped off, and then they just take it to the hospital. So
right. I actually just watched the National Geographic a week ago, and once I saw that, I said to myself, we were trying to do that. Like they beat it. They beat us.
What you have to understand, those are
it's a good project.
Right.
They have a team to develop those. Yeah. You just have a couple of
right. Yeah.
They also have
to do the same thing.
And we had to play around with different types of platforms. So we came from the Dragon Board, NXP, and then we ended up doing the Arduino. Yeah. So it's the NXPs, the Dragon Board itself. It was tough. That for some reason we're not getting no PWMs or anything like that. So and we
couldn't read the I2C for the MPU, the accelerometer. We couldn't get the signal we couldn't get the I2C to work on the HCS12. So we moved to the NXP, but then the NXP we were having trouble generating a PWM, so we scratched that one too.
Any more questions?
Good job.
All right.